Hey guys, I'm going to do a little demonstration to discuss how balanced and unbalanced forces will affect an object's motion, okay? Here I've got a bucket being supported by a clipboard, okay? The two chairs are just to hold the clipboard up to show you, okay? How would you describe the motion of the bucket? It's at rest, right? What forces are acting on the bucket right now as it is sitting on the clipboard? Normal force and gravity. Normal force is being exerted by the clipboard up onto the bucket to support it as it's resting on that surface. Gravity, of course, is acting on the bucket because it has mass, and gravity acts on anything with mass, okay? How long do you think will this bucket stay there? Well, let's keep learning, all right? Let's keep talking. So this bucket is at rest. I want to get it to move, okay? How could I get the bucket to do something other than being at rest, okay? In other words, how could I get the object to change its motion or accelerate, okay? Remember, acceleration is any change in an object's motion, okay? So I want this object to somehow change what it is doing. Brainstorm some ways that I could get this bucket to no longer be at rest. In class, some of you said that I could remove one of the chairs, okay? I removed one of the chairs, which made the clipboard no longer be able to support the bucket, okay? So if I were to draw a free body diagram to show what the bucket was doing once it no longer had that support force, I would only draw gravity down. In that case, the net force acting on the bucket would be down, and that would be gravity, okay? So gravity was the forces went from balanced to unbalanced, and the unbalanced force, or the net force, the greatest force acting when it was falling to the ground was gravity, okay? Another one of you said that I could kick or push the bucket, okay? I could apply a force to the bucket, okay? Yep, that changed its motion, all right. I applied a force greater than the object's inertia, greater than friction, to get the bucket to move. I didn't even have to make it fall off, right? I could have just pushed it across the clipboard, applied a force greater than friction, and that would be enough to change its motion because it went from at rest to moving. Again, if I were to draw a free body diagram to show that, me pushing the bucket, I would show the applied force greater in the direction that I'm pushing than the friction force, okay? So in that case, the forces were unbalanced as I was pushing it. The applied force was the greatest force. Another one of you said I could remove the clipboard, okay? Again, same thing. When I remove the clipboard, what am I removing? I'm removing the normal force. I'm removing that support force. So the only force that is acting is gravity. I want you to think in all three of those scenarios, when I removed the chair, when I pushed it, or when I removed the clipboard, what did all of those three things have in common? What happened in each of those three scenarios to make the bucket no longer be at rest? Was it that I applied a force every single time? No. In the time when I pulled the chair or when I pulled the clipboard, I never applied a force to the bucket. I did not touch the bucket at all, okay? All that happened there was I removed the normal force so that the greatest force was gravity, okay? When I pushed the bucket, I did apply a force, obviously. But the thing that all three of those had in common was that I introduced an unbalanced force, okay? The forces acting on the bucket went from balanced to unbalanced, all right? Let me show you this, okay? When I removed the normal force, gravity was the unbalanced force acting, going down. The net force was going down. When I pushed it, I was applying a force so that the unbalanced force was my applied force, okay? So the thing that happened in both of those scenarios, or really all three, was that I introduced an unbalanced force, okay? So if I asked you, what is required to change an object's motion, what would you say? Hopefully, it would be an unbalanced force. Let's look at Newton's first law. It says an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by blank. If you know Newton's first law, you would say an unbalanced force, okay? Notice that this does not say unless acted upon by an applied force. This is because you don't need an applied force to change an object's motion. I changed the motion of the bucket when gravity was the unbalanced force, okay? I did it without even touching the bucket, okay? Now, the question is, why is this bucket at rest? Is it at rest because friction is keeping it at rest? No way. When we named the forces that were acting on this bucket, we did not name friction because friction only shows up when somebody is trying to move something or when something is moving. Is anything trying to move this bucket? No. So friction is not present, okay? Friction is not the reason why this bucket is at rest. It's the fact that forces are balanced. The fact that forces are balanced keeps this bucket at rest, okay? Now, I want you to think about this in terms of our free body diagrams, okay? We practiced labeling them today. If I were to ask you to label each of these as balanced or unbalanced, okay? Hopefully you would tell me this. A is balanced, B is unbalanced, C is balanced, D is unbalanced, and E is unbalanced, okay? Which one of these, A, B, C, D, or E, or more than one, would experience a change in motion? Or in other words, which one of these would accelerate? Hopefully you said all of the ones that were unbalanced. So B, D, and E, okay? This further proves, okay, Newton's first law. Why would the ones with unbalanced forces experience a change in motion? Well, that's because Newton's first law says if there is an unbalanced force, there will be a change in motion, okay? That is why these guys, all of the ones that were unbalanced, will experience a change in motion, okay? So how do you know if an object will change its motion? If the forces are unbalanced, it will change its motion. How can you get an object to change what it's doing? Introduce an unbalanced force. How do you know if an object will keep doing what it's doing? Well, if forces are balanced, the object will keep doing what it's doing. And again, that is Newton's first law, which is also called the law of inertia, because inertia is the tendency of an object to keep doing what it is doing. Okay? All right, I hope that helps.